if you run into an issue where your application cannot handle the load. The most common solution for this problem is to increase the replica set. That means more pods come alive. Now, more pods means the application will be able to handle more load. And that's the best solution. And the problem also seems to be solved. But here's a question for you. Do you think, as a DevOps engineer, is it that simple? In real organizations, applications aren't as simple as we see in examples or in diagrams in the theory. They are far more complex. And solving these issues goes beyond just scaling up pods. So that is why it is so crucial for us to understand the practical and hands-on side of Kubernetes, not just the concepts. So this video will not only make you more confident in your interviews, but if you are someone switching into DevOps and you are worried whether you'll be able to perform the tasks given to you as a DevOps engineer, then this video will also make you more confident performing your tasks. And the best part of this video is that even if you do not have Kubernetes installed in your system, you will still be able to follow along like how replica sets and deployments are managed at an organization level. So hello everyone, welcome back to Tech World with Sahana. Today I am back with another chapter in our Kubernetes Zero to Interview Hero series. And also, if you haven't watched chapter 1, 2 and 3, Basics, Architecture and Pods, I'll mention the link in the description and also pin them to the comments. Make sure to check them out first. And here's a list of all the topics that we are going to cover today. And do stay with me till the end because there's a bonus important question in the end. So let's get started. What is ReplicaSet? A ReplicaSet in Kubernetes is simply a controller that ensures a certain number of pods are always running. For example, if you want 3 pods running, the ReplicaSet will constantly watch and maintain that state. If one pod crashes, it creates a new one. If more pods are available than the required number, it will remove the extra pod. So, in short, a replica set guarantees that the number of pods you asked for is always the number of pods you will have running. How deployments use replica sets? A deployment in Kubernetes doesn't directly manage pods. Instead, it manages the replica sets, and the replica sets in turn manage the pods. So whenever you create a deployment, Kubernetes automatically creates a replica set behind the scenes. Replica set is responsible for maintaining the pods you defined. When you update a deployment, Kubernetes actually creates a new replica set with the updated pod definition. At the same time, it gradually scales down the old replica set. This is how features like rolling update, rollbacks, and version history are possible. Because deployments keep track of multiple replica set over time. So, in short, replica set ensures pods are running and deployment ensures replica sets are managed and updated properly. So now let's start with some hands-on knowledge. And this right here is a basic structure of deployment YAML. First, we have API version apps v1. This tells Kubernetes which API group and version we are using. For deployment, it's always apps v1. Then, kind deployment. This tells Kubernetes that we are creating a deployment object, not a pod, not a service. Under metadata, we are simply giving our deployment a name, my app deployment. Now the important part is in the spec section. The field replicas 3 means we want Kubernetes to always maintain 3 pods for this application. If one pod crashes, a new one will be automatically created. Next is selector. This is how the deployment knows which pod belongs to it. Here it's looking for pods that have the label app, my app. Then comes the template section. This is actually pod definition. Inside it, we again specify metadata with labels. These labels must match the selector above. Otherwise, the deployment won't know how to connect it to pods. Finally, in the spec of the template, we define our container. In this case, the container is named my app. It runs the image my Java app 1.0 and it exposes port 8080. So what happens when this YAML is applied? Kubernetes will create a replica set for us. That replica set will then spin up exactly 3 pods using this pod template. If one of those pods dies, the replica set will automatically replace it. That's how deployments, replica sets, and pods are connected. Alright, so now let's talk about rolling updates in Kubernetes. This is one of the most powerful features of a deployment. Imagine you have deployed your Java application with 3 pods. Now you release a newer version of the image. Instead of stopping all old pods and starting all new ones together, which would cause a downtime, Kubernetes does it gradually. Here's what actually happens. First, it creates a new replica set with the updated pods. Then, it slowly replaces the old pods with the new one. Then, it ensures your application stays available during the entire process. Now, let's go back to our deployment YAML and extend it by adding an update strategy to control how the rolling update happens. Under strategy, we have defined type rolling update. That's a default, but it's good to write it explicitly. Inside rolling update, we have set 2 fields: max unavailable, max search. Max unavailable is set as 1. This means at most one pod can be unavailable at any given time during the update. Max search is also set to 1. This means Kubernetes can temporarily run one extra pod above the desired number while replacing the old ones. So we have 3 replicas. Here's how it plays out. Kubernetes might create one new pod, so temporarily 4 pods in total can run. Then it terminates one old pod, so back to 3 running. It repeats this process until all pods are replaced by new ones. This way, you get smooth rollouts with 0 downtime. Rollbacks. Now, what if something goes wrong after you update your deployment? Maybe your new image has a bug or the application starts crashing. This is where rollbacks comes into play. The good news is Kubernetes automatically keeps track of your deployment history through revisions. So each time you change something in the deployment, like the image version, Kubernetes creates a new replica set. So if new rollout fails, you can simply roll back to the previous version. And here's a command you would run: kubectl rollout undo deployment my app deployment. Now let's connect this to our deployment YAML. Suppose earlier we deployed our application with version 1.0. Then we updated the image to version 2.0 for a new rollout. If the update fails, the kubectl rollout undo command will simply roll us back to the earlier image my Java app 1.0. No need to edit the YAML manually. No need to panic. Kubernetes handles it for you. So the flow is like update your deployment YAML, then Kubernetes creates a new replica set. If it fails, roll back to the last known good replica set. Everything is automated and your application stability is protected. Alright, now that we know how to do rollbacks, let's talk about revision history. So every time you change a deployment For example, updating the image from 1.0 to 2.0 or changing the number of replicas. Kubernetes saves that change as a new version. Think of this like a version control but for deployments. This revision history is what makes rollbacks possible. Kubernetes remembers the older replica set so it can go back to them if needed. Now let's go back to our deployment YAML earlier. We started with this. At this point, Kubernetes has two revisions. My Java app 1.0, which was actually running, and my Java app 2.0, which we just deployed. You can check the history with this command kubectl rollout history deployment my app deployment. This will list out all the revisions of your deployment. You can even see the details of a specific revision. kubectl rollout history deployment my app deployment double dash revision equals 2. So here's the flow. Number 1, each update creates a new revision. Number 2, Kubernetes keeps those old replica sets. Number 3, you can see them with kubectl rollout history command. And number 4, if needed, you can roll back to any previous revisions. This means you actually have a safety net whenever you are deploying updates. Pause or resume rollout. Sometimes when you are updating a deployment, you may not want Kubernetes to immediately finish the rollout. Maybe you want to pause halfway. Kubernetes gives you the control to pause and resume. Let's say with the same deployment YAML, imagine we updated our image from 1.0 to 2.0. Now, as Kubernetes starts rolling out these updates, you can pause the rollout like this. kubectl rollout pause deployment my app deployment. So what happens when you run this command? Kubernetes will stop creating a new pod with version 2.0. The rollout stays in a paused state. You can check logs, test the partially updated pods, or verify metrics. Once you are satisfied, you can resume the rollout with kubectl rollout resume deployment my app deployment. At this point, Kubernetes will continue rolling out the remaining pods until the deployment is complete. So here's the flow. Number 1, update the deployment YAML with the new image version. Number 2, Kubernetes begins rolling update. Number 3, if you want to inspect midway, pause rollout. Number 4, once confident, resume the rollout. This is super useful in production because it gives you more fine-grained control over how fast changes go live. Now let's move to the blue-green deployment. This is a very popular release strategy, but Kubernetes doesn't do it manually. We set it up manually. Here's how you can achieve it. You have two environments, one called blue, that would be the current running version, and one called green, the newer version you are preparing. Only one of them receives traffic at a time. When the green version is ready, you switch traffic from blue to green. If something goes wrong, you can instantly switch back to blue. Let's connect this to our deployment YAML. Right now, we have one deployment. This is our blue environment, version v1.0. Now we create a second deployment for green, version 2.0. Finally, we have a service that sends traffic to one of them. At first, the service points to my app blue. When you are ready to switch traffic to green, you simply change the service selector. And now traffic flows to the green deployment version 2.0. If something breaks, you just point the service back to blue immediately. So the blue-green flow is number 1, blue, Older version runs in production. Green, newer version runs in parallel but no traffic yet. When you are ready, update service selector to green. Number 4, rollback is equal to point back to blue. Canary strategy in Kubernetes. Now, while blue-green means switching all traffic at once, Canary is about gradual rollout. You release a newer version to a small percentage of users first, test it, and then slowly expand until everyone is on the newer version. In Kubernetes, we do this manually by running two deployments side by side, old plus new, and then adjusting the replica counts or service selectors to control traffic split. Let's extend our example. We already have the blue deployment, stable version 1.0. Now we add a Canary deployment, new version 2.0, but with the fewer replicas, say 1. Now the service can be configured to send traffic to both Canary and Blue. For this to work, we make sure both deployments share a common label like app my app in addition to their unique labels my app Blue and my app Canary. So traffic distribution depends on replica counts. If 4 pods from Blue are running, 1 pod is from Canary, so 20% of traffic goes to Canary. If Canary works fine, you increase its replica to 3 and decrease Blue's replicas. Eventually, Canary takes over 100% traffic and you just delete Blue. And this is the flow of a Canary release. Number 1, start with mostly Blue, that is the stable version, plus a few Canary pods, that is the new version. Monitor logs, metrics, errors. Number 3, gradually scales Canary up and Blue down. And number 4, if there's any issue, delete Canary pods. Blue continues serving traffic. This way you minimize risk by testing newer version on a small set of users before everyone gets it. Image updates. One of the most common reasons we update a deployment is to use a new container image version. Maybe our developer built my Java app 3.0 and now we want to roll it out. The update can be done in 2 ways. Number 1, update the deployment YAML. In our deployment file, we simply change the image tag. After editing the YAML, we apply it again with kubectl apply-f myappdeployment.yaml. Kubernetes will detect the image change, create a new replica set for version 3.0, and perform a rollout update with max search, max unavailable rules we saw earlier. Number 2, update directly with kubectl. Instead of editing the YAML, we can update on the fly. With kubectl set image deployment my app deployment, my app equals my Java app 3.0. So here in this command, deployment my app deployment is the deployment name, my app is the container name inside the pod specification, and my Java app 3.0 is the new image. This command immediately triggers a rollout. And this is how you can achieve the verification. After updating, we can check the rollout status with kubectl rollout status deployment my app deployment. We can also confirm which images are running with kubectl describe deployment my app deployment grep image. And this is the flow of the image update. Number 1, change image via YAML or kubectl set image. Number 2, kubectl creates new pods, that is new replica sets. Number 3, traffic shifts gradually to new pods. Number 4, old pods terminate once new pods are healthy. So image updates are essentially the trigger for most rollout. Scaling deployments. Scaling is about increasing or decreasing the number of pods running in your deployment. This ensures your application can handle more traffic, that would be our scale up, or save resources during low usage, that would be our scale down. So first way we can achieve it is scaling via YAML. In our deployment file, we control scaling with replicas fields. Here, changing replicas from 3 to 5 means Kubernetes will ensure 5 pods of my app are running at all times. We then apply the YAML. kubectl apply -f my app deployment.yaml. Second way we can achieve it is scaling via kubectl. You can scale it directly from the CLI with kubectl scale deployment my app deployment --replica equals 5. This immediately adjusts the number of pods without editing the YAML. Next, you can verify the scaling with this command kubectl get pods. You will see 5 pods are running. And this is the flow of scaling. Number 1, set the desired replicas with YAML or with kubectl scale command. Number 2, Kubernetes adjust by creating or terminating pods. Number 3, ReplicaSet ensures exactly the requested count is running. In later chapters, we will also see horizontal pod autoscaler, which can scale deployment automatically based on CPU or memory usage. But for now, this is manual scaling. Now, as promised, here's your bonus question. When to use which deployment strategy? Now that we have learned about rolling updates, Canary, and blue-green deployments, the question is when should you use which one? First, let's see when should you use rolling update. So this is the default in Kubernetes. Use it when you want simple gradual update without adding too much complexity. It's best for regular feature release and minor version updates where you are confident the newer version is stable. Downtime is avoided because traffic shifts gradually from old pods to new one. Next is when to use Canary deployment. Use Canary when you're not 100% sure about the newer version and want to test it with the small percentage of users first. It's best for critical application or risky changes where you want to minimize impact. If Canary pods runs well, you can increase traffic step by step until rollout is complete. Next is blue-green deployment. Use blue-green when you need very fast switching between old and new versions. You maintain 2 environments, blue and green. Once green is ready, you simply switch traffic to it. This is great when you want instant rollback. Just flip traffic back to blue. It requires more resources because you are running 2 environments at the same time. So which one is the best for zero downtime? All 3 strategies can achieve zero downtime if used properly. Rolling update is zero downtime by gradually replacing pods. Canary is zero downtime since both versions run together. Blue-green deployment is zero downtime since traffic flips instantly. The choice depends on the situation. Using rolling updates for simplicity, use Canary when testing new uncertain releases, and use blue-green when you need instant rollback and can afford extra resources. So that is it for today's session. With this mixture of theory and practical, what you should do next is practice small scenario-based questions where you tweak and modify the YAML files and see if you can solve them. For that, I have already prepared multiple Kubernetes playlists where each scenario is there in the form of a YouTube short. So if you want to binge watch them, because eventually these playlists will have like hundreds of scenarios. So if you want to binge watch them, go ahead. If you want to do one scenario at a time, you can do one shot at a time. And suppose you want to do a set of it, like suppose 10 videos altogether, then the set video is also available. And I will make sure all these links are mentioned in the description and in the comments, and do not forget to check them out because this step is very crucial. And do not forget to like, share, subscribe and hit that bell icon.